Okay, so today I'm covering evaluating expressions. This is really important, especially the word evaluate and what it means, because it helps tell you what you're supposed to do. So let's start with what an expression is, and specifically we're talking about algebraic expressions. So an algebraic expression is a collection of variables and constants under algebraic operations. And so operations are exponents, multiplication, division, addition, subtraction, absolute values, square roots, all those things that you do the order of operations with. Expressions do not have inequality symbols and they don't have equal signs. So that's what makes something an expression. Things we can do on expressions, the actions, what we do to them are simplifying or evaluating. So I am focusing on evaluating expressions. So evaluating an expression is only done if you are given values to plug in for their variables. And so you need numbers that you need to be able to replace the variables with so that you can do some math. Evaluating basically means that you are following the order of operations to get a single answer. You are not solving, you're getting a number. So steps for evaluating an expression is to first replace the variables that you have with the number that it's equal to. So this is what we refer to when we say plugging in. And then once all of your variables are gone, you go through the order of operations to simplify and get it to a single number. So that's what it means to evaluate an expression. So I have several examples with different types of order of operations you can do to these things, different variables, different types of numbers, just, a wide variety, different instructions, all that sort of stuff. So this first one here, we want to evaluate the expressions for the given substitution. So plugging in also can be, you can see the word substitute instead. It means the same thing. So on the left, I have 3q when q equals 5. So step 1 is to replace q with 5 because q is equal to 5. And so we have 3 and you assume that it's multiplication. When you have a number next to a variable, you always assume it's multiplication, and we use the dot for multiplication. So it's 3 times q. And so you're replacing that with the number that q is equal to, which is 5. So it's going to be 3 times 5. And then you just do the order of operations, which in this case means we just multiply. So 3 times 5 is 15. And that is the answer. So let's look at the one on the right. We have 1.1 plus t plus s when t equals 93.2 and s equals 11.5. So we're replacing both t and s, and you need to make sure you put the correct number in the right place. So we're starting with 1.1 plus t plus s. So 1.1 plus t, which is 93.2, and then plus s, which is equal to 11.5. So then we're going through the order of operations, and when you have addition, you go left to right. So 1.1 plus 93.2. On my calculator, that gives me 94.3. So I have 94.3 plus 11.5. And so then I add in 11.5 and we get 105.8. So that is the answer. Next, we're going to write the English phrase as an algebraic expression, then evaluate each expression for x equals 4, y equals 2, and z equals 10. So we're doing two things here. We're first translating the English into math, and then we're going to plug in our numbers and evaluate. So on the left, we have 3 times z squared. So I've got the number 3. Times means multiply. And then z squared, that tells us it's an exponent of 2 on the z. So this is going to be 3 times z squared. So that's the translation part. and then we're going to plug in. And whenever we plug in with variables or with an exponent, you put your thing you're plugging in parentheses. So z is equal to 10. So I'm going to have that in parentheses 10 squared. So now order of operations. Order of operations says exponents happens before multiplication. So I need to square the 10. So that's 10 times 10. So that's going to be 3 times 100. And then I can do that multiplication, and that gives me 300. On the right, we have the absolute value of, and so absolute values, those are your vertical bars. And everything after the of is what's inside the absolute values of everything after. So I have absolute values, and then I'm going to have this next thing translate. So it actually, with absolute values, it helps to translate the stuff inside before you add the absolute values. So inside the absolute values, we have the difference. So difference means subtraction, and that subtraction sign is going to go where the and is. And it's the difference of x and 8. So what this means is that when we translate this, I have x minus 8 inside the absolute values, because everything after the first of the absolute value of that whole thing is going inside the absolute values. And so then we had to translate, we had to kind of work inside out. So now that we've translated that, now we need to replace x with what x is equal to, and x is equal to 4. So this is going to be the absolute value of 4 minus 8. So order of operations says you have to simplify inside the absolute value before you take the absolute value. So I need to do 4 minus 8 first. So 4 minus 8 gives us -4. So that's inside the absolute values. And then when you take the absolute value, it becomes positive, because it makes absolute value makes everything positive. So the absolute value 4, or of absolute value of -4, is equal to a positive 4. So your final answer is 4. Okay. Now here it just says evaluate each expression for x equals -3, y equals -2, z equals 16. So it doesn't have, like the first one we had, it said for the given substitution. This one, it's more similar to this. We didn't have to write the phrase. So we're evaluating for, and then it's telling us what these variables are equal to. So I've got 2z, so that's 2 times z when you see a number and a variable, plus that -y. So a negative in front of the y like that is a -1 times y. So that's very helpful to write that negative as a -1. Just to, when you start dealing with negatives, it kind of helps you avoid errors. So if you see -y, make it a -1 times y, because that's what it is, and then minus x. So I replace, I've got 2z, so z is 16, so it's going to be 2 times 16. And I like to do my multiplication with parentheses. You can do the dot. I use parentheses just because once we have negatives, it's easier to see, just to keep it apart where the negatives are. It doesn't look like subtraction. So then I've got a -1 times, and then y, and y is equal to -2. So now I've got a -1 times a -2 minus x, and x is equal to a negative. So that's a -3. So I put -3 in parentheses because we ended up with a minus, and then we're going to have a negative. And when you put those next to each other, it could get confusing. So whenever you plug in a negative, put parentheses around it. And just a good habit is to put parentheses around every number you plug in, because you're usually multiplying it by something. So now we've got several steps of multiplication going on. And when you've got multiple multiplications, you go left to right. So we have 2 times 16, which is 32. And if it's separated by a plus, you can do the other multiplication as well. So that's -1 times -2. which is a positive 2. And then we've got this minus a negative 3. So I really like to write subtraction as adding a negative because it helps avoid errors. So if I had done that at the beginning instead of minus x, I would have written plus negative x. And in fact, I would have written that as plus negative 1 times x because we're plugging in. So when you do that, this becomes plus negative 1, and then in parentheses, negative 3, because that's what x is. And so now I can do that at the same time. Negative 1 times negative 3 is 3. It helps avoid sign errors. So you don't have to turn subtraction into a negative, but if you're not very good with negatives, it's easier. It will help eliminate errors. So I strongly recommend that you do it. So now I've just got this series of addition. So I just go left to right. 32 plus 32 is 34. So 34 plus 3, and that gives me 37. So now on the right here, we've got the square root of z plus the absolute value of z. And there's a negative in front of the square root. So I'm going to write that as a negative 1 times the square root of z, just to help with our errors or, possible errors with your negatives. And then I've got plus absolute value of y. So negative 1 times, and then the square root of z, and z is equal to 16. So the most common error is putting the wrong number in the wrong place. So if it helps, you can kind of color code, and that could, kind of help you keep track, like maybe write all of your x's in one color, y's in another color, z in another color. And then you can, kind of follow the colors. So you know what numbers get plugged in where because they're matching colors. So I got absolute value of y. So that is negative 2. So when you've got this going on, we're doing the square root first, and I can actually do the absolute value at the same time. So the square root, so I've got negative 1 times, and then the square root of 16 is 4. So I'm going to have negative 1 times 4. And then the absolute value of negative 2 is positive 2. So you want to be very careful. My absolute values started looking like parentheses. You want to make sure they look very straight so you don't get confused. So now I have multiplication. So I have negative 1 times 4, which is negative 4 plus 2. And then negative 4 plus 2 is negative 2. All right, and now these are my last two examples. So we're going through fairly quickly here. We're going to evaluate each expression for x equals negative 2, y equals negative 4, and z equals 6. And notice we may not use every variable in our expression when we evaluate. That's completely fine. So I've got 4, and then in parentheses, 2x minus z. So this is 4, and then we're going to be multiplying because it's parentheses. That's 2 times x. And then I'm going to write this minus z as plus a negative 1 times z, just to get in the habit, avoid possible errors with your signs. So I'm going to replace x. So x is negative 2. So I'm going to put parentheses around that. So that's going to be 2 times negative 2 plus negative 1. And then z is 6. And yes, I have lots of parentheses here. So you just have to kind of keep track, make sure you've closed them all. So order of operations, you work inside out. So inside the first set of parentheses is where we work. So we need to simplify. I can get my pen working. There we go. This before we do the outside set of parentheses. So inside, we need to do the multiplication that we have. So I've got 4 parentheses, then 2 times negative 2 is negative 4, plus the negative 1 times 6 is negative 6. So order of operations, I need to do the addition inside the parentheses because you use parentheses first. So that's 4 times negative 4 plus negative 6 is negative 10. So we have 4 times negative 10 now, and that gives us negative 40. So now last one here, we've got 2z minus y over x. So that's going to be 2 times z. And instead of minus y, I'm going to write -1 times y. And then over x. And make sure that your 2's and your z's look different. I make sure that I write my z's differently. I try to curve my 2's. Sometimes I don't always do this, but I try to keep my z's and 2's different so I don't get confused. It's really important to be very careful about how you're writing so that you can, not get confused with your own work. So 2 times z, and z is 6, so that's going to be 2 times 6 plus -1 times y, and y is -4, so that's going to be in parentheses times -4 all over x, and x is -2. So when you're simplifying a fraction, you do multiply, or you do the top and the bottom separately, and on the top we have multiplication we need to do first. So I have 2 times 6, which is 12. And -1 times -4, which is 4. So I have 12 plus 4, and then divided by -2. So I have to add 12 plus 4 first. So that is, and actually, once I get to this point, I kind of like going sideways. I should go, top, bottom, but I'm kind of running out of room here. Let me see if I can squeeze it in. So 12 plus 4 is 16 divided by -2. And then fractions are division. So 16 divided by -2 gives us a -8. And that is your final answer. So that's it. So that's evaluating expressions. These variables are basically just placeholders for numbers, and you can replace them with any number you want. Generally, you're told a specific number that you're going to be plugging in, and then you just, replace it, and then you do your math. So if you have any questions, just let me know. Send me an email.